Okay, six C and D. Um, uh, Pretty heavy into the very beginning of the course on continuity and differentiability and the squeeze theorem and stuff like that, and L'Hopital's rule kind of at the end, but first semester stuff. Okay, here's what they tell you. They tell you L'Hopital's rule works. Okay, and they also tell you, oh, okay, so to use L'Hopital's rule, you know it has to be 0/0. That's how L'Hopital's rule works. So it's got to be 0/0. That's one thing. The other thing that we know is the actual answer to the limit is 4. Why? Because they tell us it's a differentiable function, which I think they say it's twice differentiable. H is, I think, differentiable or twice differentiable in the question. So here's the deal. If a function is differentiable, then it's continuous. If it's continuous, what do we know? The function value has to equal the limit. And that's going to be important later on, too. So if a function is continuous, okay, if a function is differentiable, it's continuous automatically. Because the other's contrapositive also works. If it's not continuous, it's not differentiable, right? So if it's differentiable, it's continuous. If it's continuous and we know h of 2 is 4, then we know that the actual limit to this answer has to be 4. Okay, so there's two things we know to answer, and we need two things because we need two equations because we're solving two different things, f and f prime, right? So what do we know? We know that the limit is got to be 4 when we're done. But at the moment, we know we have to use L'Hopital's rule because it says so in the question. It gets convoluted question, just be aware of that. So, so what we know is this limit has to not only be 0/0, but when I eventually work that 0/0 out, I've got to get 4. Okay? So let's just use some common sense. Obviously, x is 2. Put the 2 in, negative 0, no problem. That would mean f has to be 1. Now, I kind of wrote it, you know, I'm being a little cheesy here in writing it, because that means f of 2 has to be 1. F of 2 has to be 1. So there's the first one. Now, the next one is that, okay, if we apply L'Hopital's rule to answer the question, because it said if we use L'Hopital's rule, we'll get the answer. We know the answer's got to be 4. So remember how you do L'Hopital's rule. You take the derivative of the top, and the derivative of 4 and 1 are 0, and derivative of x squared is 2x. And then, now be careful with the bottom. The derivative with respect to x, but that's f, right? So it's 3f squared times f prime, because you have to do a chain rule because of the f, right? It's not x. It's not x to the third. It's f to the third. So now here's the deal. This we know has to be 4 because we know the final answer is 4. Why? Remember, going all the way back to the original, the very top of the test question, it said h of 2 equals 4. Well, and it said it was differentiable. So if it's a continuous function, because it's differentiable, and we know h of 2 is 4, that means the limit has to eventually be 4 when we solve it. So that's got to be 4. We know f is 1. So I get 4 over negative 3f prime. So f prime would have to be, oh crap, negative 1/3. Hold on, I put a negative on that. Negative 1/3. So the negative 1/3 and the 1. Now the next one, again, I don't think, it's not a great question either, in my opinion. But again, what is it? So they tell you that k is smashed between g and h. Here's the thing, just common sense tells us this is true. And here's what I mean. Here's just kind of what I mean by the common sense. We know g of 2 is continuous at 2 and h of 2 is continuous at 2. And since this is smashed between it, it's got to be continuous at 2 too. But let's go back to the rules. What does it mean? It's got to have a function value of 2 and it's got to have a limit of 2. So let's get into the minutia of the math here. We know, so if this is true, then we know two things. We know if I put 2 in, it's got to be between, and if I take the limit, it's going to be between. This is what we call the squeeze. This is called the squeeze theorem. You probably should write that down, the squeeze theorem here. Just I don't know if they penalize you if you didn't say that, but if a function is trapped between the two functions, then the limit is also trapped between the two functions, obviously. So it's called the squeeze theorem. So again, it seems really weird, but we know g of 2 and h of 2 are both 4, so that means that k of 2 has to be 4. Here, we know that since this is a continuous function, and that's a continuous function, we know that these limits have to be 4. But by the squeeze theorem, the limit of k has to be between there and 4. Well, if k of 2 is 4, it has a function value of 4, it has a limit of 4, then we say that it's continuous there. And so that's how you do that one. Okay?